Hey guys, welcome back. So today we're working on this Honda EU2000i. This machine was dropped off by a local viewer, Phil, who's actually the captain of a barge. He said this machine is used on the docks to power lights. It's always done a great job until recently when it stopped making power. So he dropped it off hoping that we could fix it, and likely we can. But my concern is that these usually fail due to a bad inverter module. And if that's the case, then the cost of the repair might exceed the cost of the machine. That said, though, I'm not so sure it is a bad inverter because he did add one bit of information that raised a red flag, and that was that someone replaced the starter recoil rope around the time this happened. And apparently they didn't put enough tension on it. So we'll have to dig into that at some point. But for anyone that has changed a rope on one of these, you know it's not an easy task. You do have to remove the clamshell, and you actually can't get the recoil off because the inverter module is in the way. So I'm thinking somebody may have unplugged some wires or potentially damaged the harness, causing the issue that it has now. So we'll dig into that. But before we do that, he has had it running a few times in the condition that it's in. And I think we should do the same just to see with our own eyes kind of the starting point, and then we'll dig in and fix the problem. So I've got a light plugged in and turned on, as well as the kilowatt. The main breaker is not tripped. So when we get the machine started, we want to pay close attention to these indicator lights. If they're dark, that tells us that the module is likely bad, or the stator. If they come on and it's blinking red, that also indicates a bad inverter. But if the light lights up green and stays solid, then that'll indicate the inverter is online and working properly. Now, starting this, it is a little bit risky because the throttle is not a mechanical governor. It's actually a stepper motor that is controlled electronically by the inverter. So if we have a bad inverter, then we're gonna have no control of the engine speed, and it may race out of control. So we're going to have to shut it down quickly, which brings us to the next problem. This has been modified. Usually you would just turn this valve to off and that would kill spark. But in this case, it just shuts the fuel supply off, and then it runs for another minute or two before it stalls out. So this kit does come with a momentary switch to kill spark, but it is damaged and I'm not sure it works. So I think before we start it, I am going to pull the access panel to the spark plug, so that way we have a way of shutting it down if needed. Okay, and that gives us good access to the plug wire. So if we need to shut it down quickly, this will be a good option. All right, the vent is on, eco switch is off, so it will run at full speed. Choke is on, fuel is on. And that was a pretty interesting test. So the good news is it started first pull. And the engine sounded good, at least until I turned the choke off, and then the engine speed went pretty fast. It actually was fairly loud and was breaking up, so we may have been floating the valves at that speed, which is not a good thing. Basically, the valves can't close fast enough for the speed that the engine's running. But the one thing I did notice, besides the fact that the light didn't turn on, is that we had a green light on the inverter module, which says everything is good, yet we had no power output, and we also had no throttle control, because I did turn that eco switch on, and at no time did the machine try to slow down. So let's pull this cover off, let's look around, and see if we can find any unplugged wires. And you can just get a glimpse there of the back side of the inverter. So from what I can see, the wire harnesses are plugged in, and there is no obvious problem here. So yeah, let's keep going. Let's dig a little deeper. Let's get the clamshell off. That way we can get a much better view of what's going on inside. So I'm pretty sure that valve can stay. That's actually behind the plastic, but we do need to remove this screw, which will separate, this outer skin from this black piece of plastic. I think we can leave the recoil rope in place. And hopefully all these come out. Being that this was used in a marine environment, it can have a negative effect on the fasteners, but so far, so good. And of course it was recently apart for the recoil rope, so we know at least the outer clamshell should come off. That one was loose. And we've got a couple more on this side down below. There's like a trim piece that has to be removed. Actually, I think we need to remove this side first. And by remove, I just mean remove the fasteners. That will allow it to pull out just a bit. Ooh, that one is stuck. There we go. I guess the secret on this is that you have to pull the top back a little bit. There's a little tab that kind of allows it to slide down out of place. And it looks like just two 10mm bolts here, one on each side. Huh. That one's pretty stuck. Yeah, that does not feel good. So maybe these weren't removed when the recoil was changed. There's one bit of corrosion. Let's try the other side again. I'm actually going to try tightening it a little bit. And it's moving, but it's tightening it up as I'm loosening, so there is corrosion on the threads for sure. So I'm gonna have to go back and forth until things start to loosen up. All right, and in theory, this should come out. Should. There we go. And let's do the other side. And we're probably not going to be able to get this one fully off because there is a switch attached to the clamshell. Let's see if we can get this disconnected from the switch. So the kill wire, it's just held in place by these two screws, which are pretty rusty. And I can't get a bite on them. So, you know what, let's just cut the wires. We probably need to replace the switch anyway, but it might be easier to break those wires free off the machine. Or I should say break the screws free from the wire. But given the amount of rust on them, they may not play nice. Well, we're in, but as you can see, it doesn't give us a whole lot more access. And again, to replace the starter recoil, you need more access. And you know, I'm thinking the guy before me must have had this apart more than it is now, but looking at these fasteners, I'm not sure that's the case. So it makes me wonder, how did he replace this rope? I'm not sure, but I think we need to keep going here and actually get the tank out of the way, as well as these supports, and then we should have plenty of access to the wiring and the recoil. So I'm pretty sure we just removed this guy. And we might be able to feed this whole assembly through the hole without cutting anything. You know, as far as the valve goes, that's going to stay on this structure, so we're going to have to probably disconnect some fuel lines. And yeah, that will go through. The tank is actually just in the way, so let's work on that problem. Yeah, that has not been removed, I would say, ever. Might need the impact for that one. Yeah, a lot of corrosion on that one. And the tank is quite full, so I'm going to bring that fuel level down quite a bit before removing it from the machine. And a lot of sediment just came out too. So that's why I use the coffee filter. Actually, we just got a chunk of something. So definitely some debris in that tank. So that's another good thing about, you know, siphoning the tank empty like we're doing right now. You kind of suck up all the chunks that might be in there as well. So once I get most of this out, I'll just show you the stuff that got filtered out by that coffee filter. And there's a look at what the coffee filter filtered out. So yeah, it just looks like some dirt, maybe some sand mixed in with that fuel. So yeah, not ideal, but there is a filter in the tank that would prevent any of that from making it to the carburetor. So we need to get these two lines disconnected from the fuel pump. The top one, I believe, is just the fuel line that runs over to the carb. And the bottom is the impulse line. That's what drives the fuel through the pump. And once these are off, we can try to get these screws out down here on the bottom, which are also corroded in place. And I think this piece and the tank will come off together. Now, there is also normally some wires on this switch to kill spark, which they should be bypassed. So likely we don't have to do anything there. Yeah, and like the other side, these are corroded in place. There's one. And unfortunately, this is a plastic piece, so we can't apply any heat here. Nope, it's not moving. Does not want to move. Let's try making it a little tighter here. Something happened, and I don't think it was a good thing. No, not good at all. So the bolt actually didn't come out, but this housing that was retaining it is plastic, which I'm kind of surprised about. I thought it was metal. Anyway, that is an issue. That we're going to have to deal with. So we do have an issue here. This wire is unplugged from the board. And this is the wire that runs over to the servo. So for sure, that's a problem. Although I'm not sure it's going to explain the lack of power. But we should have engine speed control back, assuming the inverter is good. This output here, this wire, I think this is the one that's the main 120 volt out that runs over to the control panel. And that one is plugged in. So potentially the overspeed situation was maybe preventing the inverter from outputting the power, but the fact that we had a green light says otherwise. But let's just check these other wires while we're here. And I'm thinking we should restart it now that the servo is plugged in and see if the power output problem is fixed and if we have control of the engine speed. All right, let's try this again. Lights plugged in, turned on, eco switch is off, choke is on. So I'm hoping this time, now that we have the servo plugged back in, we should have throttle control if the inverter is working at all. So let's give it a try. Well, the good news is we have throttle control. Eco throttle works. Carb, not running well. We did have to partially choke it, but the good news is we do have control now of the engine speed. This time, like last time, no power out, but we had a green light. So I'm very suspicious of the fact that we have that green light. You know, that tells me it should be producing power. So I'm going to try to remove these fasteners from the front of the control panel so that we can get access to the inside, and we'll do some probing around, see if we're getting power anywhere on the 120 side into this panel. Okay, that one's coming right out. Well, I think I may have found the problem. You guys can't see it from your angle, but on first look, it appears good, right? We have the harness coming in. We have a red wire and a white wire. So we have the live wire and the neutral. Neutral goes right to the outlet and then jumpers over to the parallel port. And the live wire comes in here and splits off. One goes direct to the parallel port, and the other one comes over here to the circuit breaker, and then comes out of the circuit breaker and goes right to the plug. So looking at it from this angle, it looks good. But if you look at it from the side, I think you'll see the problem. And if you come down and look at the wire going into the breaker, you can see that it's not fallen off, but it's certainly not plugged in like it should be, you know, like it is on the output side of things. So if we plug that in properly, that might fix the issue. Although I'm not so sure about it. I mean, although it wasn't plugged in all the way, it wasn't unplugged either. So let's just test the breaker real quick and make sure we can get a low reading through it. Yeah, breaker's good. 0.2, 0.1, so a nice low resistance connection. So let's get this plugged in fully, and we'll start it again. See if there's been any change. All right, let's try it again. Now that the wire is fully plugged in, maybe we'll have output, but I'm not so sure. You know, that wire, although it wasn't fully seated, it wasn't unplugged either, so I kind of doubt that was it. But let's find out. So yeah, that was not the problem. Although not ideal, it was still making a connection. And the fact that we pushed it on a little bit more didn't make any difference. We're still not creating any power on the 120 out. So we could test directly on that wire, but I'm thinking we should backtrack even further, maybe to the board where those wires come out. So I'm going to unplug that connector. We'll get the machine restarted and see if we measure any voltage coming out of the inverter module. So this white wire right here looks suspiciously loose. Like that should not be moving around like that. So is that the issue? I think it is. Let me cut this back a little, or maybe I can unwrap it. Interesting. So this electrical tape I don't think is factory. I think someone was in here and maybe covering up the mistake they made, because that right there is a broken connector. So the good news is the inverter is fine. The problem is a bad connection to neutral. So let's be sure of that. Let's probe it right there while running and make sure we see 120 out. So I'm going to get the engine started again. We're probed into the main output of the inverter. So all this stuff is bypassed, but the power should come out on these test leads into the meter. And if the inverter is working, we should see somewhere around 120 volts. All right, fuel is still on, choke is on. Keep an eye on the meter. Here goes nothing. And that's all it was, just a broken pin on this harness. So luckily, that is an easy fix. You know, if I had the right pin, we could just cut this one off, put on a new, and we'd be back in business. But I don't have the correct pin for this machine. And although we could probably locate it, there's really no need. You know, this harness, it is still available. It's not that expensive. I think it's just over $20. So I'm just going to order up a new harness, and then we'll have power reaching the control panel. The owner, I also spoke to him. He's going to order up a new momentary switch for the top of the machine. And as far as the damage here goes, haven't quite decided, but I'm leaning towards leaving good enough alone, because if we want to swap out this tray, we need to remove additional fasteners and potentially cause more damage. Not to mention, the same plastic piece on the other side only has one fastener, which is good enough for that side, and this side had two. So now we're down to one. Is that going to be a problem? I don't think so. If it is, that's a bridge we can cross when we get to it. So while we wait for the parts to show up, there's still a few things we can do. I want to increase the tension on this starter rope. I also want to take it off and just inspect to make sure everything was done right, which I know it wasn't based on what we saw over here. This damage was caused by someone not taking it apart to the level that it is right now to service this rope. Not to mention, it's not even tight. These bolts were never torqued down. They were not even finger tight. So yeah, this area needs some review. Also the carburetor, although it runs the engine, it doesn't run it well. So we need to pull that off and get it cleaned up. And then the last thing I want to tackle is this fastener right here, which technically we can't use due to the fact that the plastic broke, but I do want to extract it, because at some point in the future, if we replace that tray, I need to know whether this piece is good or not. If we can't get this fastener out, then a new tray isn't going to be any help, and we're also going to have to replace this part as well. So yeah, let's actually start here. And now that we have access to the back and better access to the front, I'm willing to bet that we can get this out. So I'm going to try the impact again. I think part of the issue was that, this backside was being held in place by plastic. So every impact was flexing the plastic instead of transferring the energy into the fastener. So I'm hoping now that we can hold the backside still, that maybe we can get this to come out. Yeah, not a problem. We still have a fair amount of the channel here, and this still captures the nut pretty well. So I think we are going to run with this base plate, and we will still use two fasteners. So let's go ahead and get this off. I'm also noticing we have a zip tie here with, something held out of the way. So that's a cap actually for the bolt. And the zip tie should not be there, so we'll cut that off. Yeah, so no issues here with that knot. That looks correct. Although the rope length is excessive. I'd say that's maybe a 6-foot cord on there. It's hard to even show because it won't all fit in frame. But this is way more cord than you need on something like this. So the fact that it won't wind up anymore, likely it's not because there's not enough tension. Actually, it is fully tensioned when the rope is fully out. Problem is, the rope is just too long. So we're going to take some of that off, maybe about a foot. Yeah, that's a problem. That knot's pretty tiny, and it's actually halfway pulled through. So that one definitely needs to be fixed. right, so we'll get this piece back on. And then the metal part. And we'll give that 2 knots so that it doesn't pull through like it was about to. So that right there should do it. Get the cap back in place. And that should be good to go. And still plenty of length on here. And the knot in there looks good. So I see no reason why we can't get this back on. So I'm thinking before we get the carb cleaned up, I do want to go through this tank. You know, we drained it most of the way, but there is still fuel in there. And there was also debris in there. So I want to rinse it out, just get all the debris out. And there's also a filter in here as well that we need to clean up. All right, so we got that plugged off with the vacuum cap. And we'll just remove the fill. And there's no lip on this tank, so we should be able to dump it all out. And not much for fuel or debris, so that is a good sign. The filter was a bit dirty, and I guess still is. So we'll clean that off real quick and get it back in the tank. And we're going to leave the tank disconnected for now, but I'm going to put the plug back in just so we don't leak anything. And let's get the air box removed. This is probably the only bolt or screw that this screwdriver is good for. This is actually for ski bindings, probably made in the late to early 90s. Not really meant for this type of work, but it is very good for getting bowls off the carburetors. Filter's in good shape. And before we get it fully off, we do need to disconnect the wires that run to the servo. So this cap is removable, and the harness you can unplug from the servo. So I think the first thing we're going to do here is just get these lines off and kind of out of the way. So that one is just a vent. This is the bowl drain, which we're going to drain before we pull the bowl off. And before we actually open this up, we do need to remove the servo because I do want to soak this in the ultrasonic, and this servo, or actually it's a stepper motor, cannot go in the ultrasonic. So once this is removed, we can put this through without any concern. Now, normally I do need an impact to remove these two screws that hold this on. Even with a JIS screwdriver, these tend to be difficult without stripping them out. Although I say that, and this one just came out. And so did that one. So maybe I'm not the first one in here. Now, you want to be careful and hold this together. You don't want it separating until you're ready, because there is a little plastic piece and a spring, which you can just see right there. And if you just pull this off, then that piece and the spring, they're going to launch somewhere, and you're not going to find them. So just hold them in place, get the servo off, and once that's removed, you can safely get this piece of plastic and the spring out and set that aside. And at this point, we just have a normal carb. So we have an adjustment here for the pilot jet. It is maxed out right now. There is a limiter on it. So turning it to the right, that leans it out a tiny bit, and to the left, richens it up, which it was fully to the left. So we're going to leave it like that. And let's get that 8mm out from the bottom. Actually, it's a 10. And yeah, that doesn't look great. So that kind of looks like rust. It might be varnish. Either way, that's likely the cause of the surging. So we do need to clean that up. Some of that got on the pilot circuit, I would say. The float and the needle look good. Let's see if we can get that main jet out, as well as the emulsion tube. And yep, that is coming right out. And there's the emulsion tube. So that actually looks pretty good. Main jet, I don't suspect is a problem. I can see right through it. Likely the issue is the debris in the bowl and the actual pilot jet. So we just need to remove the idle set screw. And that jet should lift right out of there. Like that. And that is pretty much it. So I'm going to run through some of these smaller passages, make sure they're clear. We'll soak this for about 10 or 15 minutes and see if the stuff cleans up. And I am dangerously low on carb spray, so we're going to make this count. We're going to blow through here. With carb spray, we should see it exit down here if the pickup is open. Yep, and that's functioning fine. So then I'm going to plug that, and we'll blow through this way. And if everything's clear, we should see some spray exiting right toward the front of the throat. And actually, I'm not seeing it. So let me hold this open. We'll do the same thing. Yeah, there's a little bit coming through, but I would expect to see a little bit right here up front. And I'm not seeing that, so that might be plugged. And that would explain the surging. So I'm going to work at this a little bit more and see if we can get anything to come out right there. Yeah, and I'm seeing hints of it, but not a whole lot. And I'm just about out of spray, so we're going to let the ultrasonic work its magic, and we'll try it again once the carb has been cleaned up. So we'll get some Simple Green Pro into the ultrasonic. Regular Simple Green works actually better, but this is safe for metal, whereas the regular Simple Green is not. So if you're going to use the regular stuff, I would keep it to about 10 minutes or less. Otherwise, you're going to potentially see some etching on the metal. So the carb cleaned up pretty well, and the bowl looks basically like brand new. So let's test the pilot circuit again and see if we have any flow out of that opening right in the front. Yeah, and we do. So that is a big improvement, and I think this will run pretty well. So let's get it back together, just starting with the emulsion tube and the main jet. And then we'll get the needle and the float back in. As well as the pin. And it's always a good idea to just flick this a few times, because the needle, if it's not perfectly centered, it will flood over the first time you fill it with fuel. So by doing this, you kind of minimize the chance of that happening. Then we get the bowl back on with the bolt. And for most carbs, you want to have the bowl drain facing opposite the fuel inlet. But on this machine, you want to have it more facing forward. Then we'll get the pilot back installed. Make sure that is fully seated. Like that. And the idle set, Now this machine does idle, but it is servo controlled, so you don't really need to worry about the screw too much. So just turn it in until you see a couple threads poke through like that. And then we can get the spring back in, as well as the plastic piece that connects the throttle plate to the stepper motor. Like that. And last but not least, we want to get the stepper motor back, and it has to be keyed into the throttle. Like that. And then just lock it down. And that's it. So let's try it out. So we get these lines reconnected. This here is just an overflow. And this is more a vent for the overflow. So we'll get that resecured with the plastic clip that is right up here. Like that. And then we have this line right here, which is for the drain. So we'll get that reinstalled. We'll get this resituated, and that is the final connection, at least for the carburetor. Then we can get the airbox on. So I think it's time we check the oil. It's usually the first thing I check, but in this case, I didn't want to take the cover off and potentially see an issue before we tried fixing it. So the oil, it is well used, and it's in the safe zone, but definitely on the lower side. So I say we run it one more time, see if the carb runs it any better, and then we should change the oil. So now that the carb's cleaned up, we're hoping that it's going to run better with the choke off. Eco switch is off. Fuel is on, choke is on. Let's give it a try. So that is a lot better. Not perfect at idle, but a lot of these machines don't idle great. I'd say about 50% of them. And the way it's running right now, I don't think is any different. So we're not going to split hairs. Instead, we're going to change the oil. And when we get the parts ordered up, we can actually try this under load and make sure it's performing as expected. Well, it's about a week later, and I think we have the sub-harness we need to fix this machine's problem. That said, though, it wasn't quite as easy as it should have been to find this. Although this is branded EU2000i, there are many different revisions to this machine, and different revisions have different wiring harnesses. So to find out for sure, you need two codes. The first one is right here, the EAAJ, followed by the serial number. The second one is here, which is kind of hard to make out, but if you look close, it says 2000IA. So with these two codes, you should be able to find the exact diagram for this machine. The problem is these codes are an invalid combination. So at some point, I think someone mixed and matched parts on this machine, and as a result, you can't locate the diagram for this machine with any certainty. So I looked at a bunch of diagrams, saw many variants of this harness, but then came across this one, which appears to be the correct part. So let's try to install it, and hopefully this fixes this machine. And swapping this out should be pretty easy. We just have a couple of spade connectors right here. So this is the one on the parallel port, and the other one, which was the one that was not fully plugged into the circuit breaker. So we'll get that disconnected. Then we have the neutral wire. So again, one comes over here, spade terminal to the parallel port. Get that unplugged. And then lastly, we have the neutral on the side of the outlet. So being where it is, I'm not sure we can get a screwdriver on it without removing the outlet, but let's try before resorting to taking this out. And I can tell you right now, there's no way I can do this, at least not without removing all the wire harnesses, so that I can flip this up and maybe come at it from the bottom. So instead, we're just going to remove these two nuts right here and lift this out. Interesting. This one just kind of fell off the circuit breaker, so I'm gonna have to tighten up that spade a little bit when we get this back together. But at this point, this harness is free, so we can just pull it through. Old one on the left, and for the most part, the connector seems identical, and the length of the harness also the same, with the same connectors on the other side. So I think we're going to be good. And the tape that I peeled off the old harness may have actually been factory, although this one looks like shrink tubing, so yeah, it's hard to say for sure. All right, let's get the new harness installed. So we're going to connect the white spade over to the terminal here. And we also need a red. So that one looks like it would reach. And this one's actually too long, so we're going to use this one. And I'm going to clean off the breaker spades. They do have a bit of corrosion on them. All right, and that's it. So we got the new sub harness wired in. In theory, that should fix it. Let's plug the other end into the inverter, and we'll do a quick test before getting this back together. Yeah, I'm pretty sure we're done in here, so I am going to resecure this before we start the machine again. All right, let's try this again now that we have the new sub-harness installed. This time we are plugged in with the kilowatt and a light into the output, and we should see things power up, at least based on the testing. So let's get the engine started and find out. All right, let's try this out. We'll turn the eco switch off, choke on, and external fuel is connected and turned on. Very nice. And that's all it was, a broken wire in that sub-harness. So now that we have a new one installed, everything is working as it should. The output was 126 volts and almost exactly 60 hertz. So let's get this machine back together. So we'll just get some of this dust cleaned off. We don't know if anyone's ever going to be in here again. Hopefully not. And since we have some access, we'll do what we can to clean it up. So we'll get the tank situated kind of loosely. We have to get the plastic straps in. I guess we'll connect the fuel line as well at the same time. Yeah, technically I think we could have gotten away with one. It actually seems to be keyed. So even without any bolts, things are locked in place. The bolts just help keep it keyed. So to that end, I'm going to put some anti-seize on these. Usually I don't, just for little bolts like this. But given how difficult it was to remove, I think we're going to use some anti-seize here to help the next guy out, which likely will be me. And we'll get the starter resecured, and the tank also has to be keyed in right there, so we'll do that as well. And then we'll put the support on the other side to lock things in. And same thing over here, we just got to key that in. Keeps the tank where it needs to be. And just one bolt here on the bottom holds it in place. So I think I am going to bypass this aftermarket kit. I tried to free up those screws to get some wire in that broken switch, and it's just not happening. And to run a new switch and a new wire later on, not a big deal. It's very easy to do. So for now, we're just going to plug it back into the OEM switch to shut the machine down with. Like that. And the last big thing we need to do here is hook up the fuel line, which is the top one right here, to the fuel pump. And the bottom line, that is the impulse from the engine, which drives the pump. And before we go too much further here, let's see if we can get these plastics cleaned up at all. Yeah, that's going to clean up real nice. Yeah, this machine, it cleaned up really well. And more importantly, it's now making power and has control of the engine speed. So I think we're looking pretty good, but we should make sure. So let's bring this outside. We'll do a quick load test. We'll check the power quality, and hopefully everything checks out. Well, given that this is a Honda, I'm not expecting a lot of problems here with the load test. Now, this machine, it is limited to 120 volts, 1600 watts. So the load bank, we can't use it because that is configured for 240 volts. And just given the small size of this machine, it's kind of overkill anyway. So instead, we're going to use a 120 volt, 1500 watt space heater and a 100 watt light. So together, that'll be the max that this machine is rated for. And technically, it is going to be a slight overload. This space heater, I think, pulls slightly over 1500 watts. But, I think it can do it. And assuming it can, we'll double check the power quality under the max load. The oscilloscope will show us what the sine wave looks like. These machines produce a very clean sine wave, usually cleaner than you get delivered to your house from the utility. And the THD is also very low. Ideally, you want 5% or less. And these machines, I think, top out at about 2% THD. So let's get the engine started. We'll double check the outputs. If everything looks good, we'll put on a half load. And then we'll bring it up to the max of 1600 watts. And usually I turn the microphone gain down quite a bit when testing generators, about 12 decibels. For this machine, I'm leaving it right where it is. Otherwise, you're probably not going to hear a whole lot. So the ignition's on, choke's on, the vent is on. Eco switch, I actually think that's on. Let's turn it off. And yeah, THD extremely low at 0.1. That is much lower than the utility provides to your house. And the sine wave looks absolutely perfect. So let's put on a half load of 750 watts with the eco switch on. And if you're gonna put a sudden load on more than half, you gotta turn that eco switch off, otherwise you're gonna stall the machine. But in this case, it handled it just fine. So now we're pulling technically 850 watts, and the THD remains virtually unchanged at 0.3%, and the sine wave looks also unchanged and absolutely perfect. So we'll give this a few minutes, and then we'll bump it up to the max of 1600 watts. And no issues at all, pulling 850 watts. So let's bump it up to the max of 1600 watts. And yeah, no issues at all. So under a full load, THD, again, barely moved. We're at 0.5%. And it looks like the voltage may have come down a little bit, but the waveform still looks absolutely perfect. All right, it's been a few minutes, no issues at all. So let's take all the loads off, and we'll let the engine cool down a bit, and then we'll shut it down. So yeah, needless to say, a very impressive machine. They are very quiet, very fuel efficient, and very clean as far as the power quality goes. We just saw that. The sine wave looked absolutely perfect regardless of load. And the THD, we topped out at 0.4 to 0.5%, which is excellent. That is lower than what the utility delivers to your house. And just for comparison, let's bring in the THD meter in the oscilloscope. We'll hook it up to my utility power and just see how it compares. Got everything plugged into utility power, so I'm going to flip the switch, and you can see what the sine wave looks like. It is actually pretty good, but you can likely see there is a little bit of distortion on the peaks of the sine wave, and I think this tells the bigger story over here with the THD meter. Quite a bit higher than the Honda at 2.6%. Still safe, it's below 5%, but when you consider the Honda was at 0.4, 0.5, that is orders of magnitude cleaner than what we're getting here from the utility. And I've said this several times, but we got really lucky on this one. Classic symptoms of a bad inverter is no power out and no throttle control, which this machine was exhibiting. The thing that gave me hope was that the green light came on. And that tells me that the inverter module actually did power up and was trying to do what it's supposed to be doing. Luckily, we ended up having a wire harness unplugged, another one broken, and for $25, we got this machine up and running like it should. So, I hope this video helps someone. Thanks for watching. And maybe just a little bit of bonus footage here. As soon as I shut the camera off, like the very next morning, the new switch showed up. So we're going to get this installed real quick and call it done. So to actually get this installed, you do have to remove the airbox to give enough access to the underside. So not a big deal. Just pulling the cover, the filters, and two 8mm nuts, as well as an 8mm headed bolt right there. So I'm going to get this sticker out of the way. The kit came with a new one. We are going to have to clean this up though. And there's a nut on the bottom we need to loosen, and this should lift right out. So in theory, this is a very good ad for this machine. It's probably one of the biggest complaints is that you can't run the carburetor dry. If you want to drain it out, you have to take the cover off, crack the drain bolt on the carb to get it dry. And if you are going to store it, you want to do that, or install this optional switch, which is separate from the on-off for the fuel valve. And it seems like decent quality. Of course, this machine was in a marine environment and it didn't hold up. At least the switch didn't hold up with the salt. Now this should just lift right out, but it's not. So I'm hoping this wasn't glued in place. Yeah, it may have actually been super glued in place. So that's going to complicate things. I see a white film on the threads underneath. So let's try a bit of acetone. So for what it's worth, we're putting some acetone on. That should help free up the glue, but we can't really actually get underneath this lip, which is where, likely the bond is being formed. So we're going to have to tread lightly. I don't want to damage the case trying to get this out. May also just be a really tight fit. There we go. It's starting to come out. Yeah, I think it was just a tight fit and maybe a bit of glue. I just say that because I see all this white here in the threads, which is potentially thread locker, maybe super glue. I'm not sure, but you can see it's kind of everywhere. So I'm just using a bit of rubbing alcohol to clean up the surface, and we'll get the new switch installed. I don't think we need super glue or thread locker, so I'm going to leave it off. But we do need to put the new sticker down first. So it doesn't have to be perfect. I think that'll do. And lastly, the new switch. So technically you can install this any way you want, but I'm going to face it so that we can get the wires in easily. My concern is, can I get a screwdriver on it to actually tighten those wires up? Hoping I can. At least according to the instructions, shouldn't be a big deal. And this is going to be the tricky part. Now, according to the instructions, you were actually supposed to connect the wires first and then secure the nut, but then you can't get a socket on it, and you're going to have a hard time securing the switch. So I think either way, you're going to have problems. But I'm fairly sure this will get in there, and I guess we could move the fuel line as well a little bit out of the way and come in at it a little bit more straight on. Yeah, I'm not sure this is going to fit. The wire here on the left, actually both of them have been tinned, but the one here is kind of spread out. And I'm not sure it's actually going to go in to that little hole. And no, it's too wide, so we have to reshape that. There we go. Nice and round. All right, so now that this is reshaped more into a circle, it goes right in. Imagine that. So let's try to tighten this up. We just have to be careful. I backed the set screws out most of the way, and if they get backed out any more, they could fall into the engine, never to be found again. All right, so that's pretty tight. And we just got the green wire. So this one was tinned correctly at the factory, so that should go in. Yep, that looks good. Okay, heart part's done. And then we just need to unplug the factory switch, which I believe is the one right here in the front. So we'll set that aside. Now, one thing to keep in mind is that, this wire is pretty long. When you plug it in, there's a lot of slack. And you want to make sure that it doesn't come in contact with that starter recoil rope. Otherwise you're going to damage the rope and potentially the wire as well. So that is locked in, and the kit also came with a zip tie to secure the line right there. So we're going to do that and get the airbox back on, and we'll try it out. So we're going to try the switch out real quick, make sure it works. And assuming it does, I'm going to restart it. And this time we're just going to shut the fuel off and run it dry. Carbs, they really should be stored dry unless you're going to restart it, within the next day or two. Okay, good. The switch works. Let's get it restarted. We'll try choke. Yeah, definitely a great add on this machine. These really should all come with this kit, really OEM from the factory. That is one of the bigger complaints about this machine, probably one of the only ones, is that when you turn the fuel off, it also kills spark. So the carb is still full of fuel, and of course if you leave it like that, the next time you try to use the machine, it's not going to start. So, the easy thing is a setup like this. Of course, the way Honda recommends is that you actually pull the cover and drain the carburetor directly, which also isn't a big deal, but it does require tools, a little bit more time, and depending upon where you are, you may not have access to tools. So this ensures that the carb is ready to go the next time you need it. Anyway, now I'm done.